Okay, so first we'll do the vertical one. And to start us off, let's write down what the equation looks like. Now for ellipse equations, it always equals 1. And the top, most of the time, it doesn't really matter because it's commutative, but you can write the x minus h squared, and you can write the y minus k squared in those spots every single time. The denominators, however, those are the ones that can change. You can have the a squared underneath the x, or you can have the a squared underneath the y. Now, which one did you guys say you wanted? You want me to do the vertical or horizontal? Vertical. So because you want the vertical one, I'm going to go underneath the y because the y is vertical. That axis is vertical, and I'm going to put the a squared there, and then the b squared over here. The a squared kind of tells you what this is going to be. If it's going to be a vertical ellipse or a horizontal ellipse. And because the a squared is underneath the y, then we know it's going to be a vertical ellipse. All right, so to help us out, let's put some numbers in right here. Instead of a squared, let's put a give me a perfect square. 25. Let's put a 25 right there. And then instead of a b squared, let's put give me a perfect square that's less than 25.
16.
16, that's good. And we could have used 9 too. It doesn't matter. Just as long as they're perfect square. I mean, you could do it without perfect squares, but since we're learning this, perfect squares are nicer. So this is where we start.
Will these have to be picked at random, or will they be given to us?
Oh no, they'll be given to you in the book or in any problem. I'm just showing you guys how to graph it. And to graph it, we need some numbers to picture it. Now, I'm going to start off with the origin in the center. Or the origin's always in the center. The center at the origin. In fact, all the problems in 4.4 have the center at the origin. And so your function will not actually look like this with the h and the k. It'll look like this without an h and without a k. Because we don't need the h and the k if it's 0 and 0. Alright, so here's our ellipse equation. The origin is 0, 0. Now let's graph the vertices. The vertices are at the ends of the ellipse. So like if the ellipse was like this, your vertices right there and your vertices right there. If your ellipse was horizontal, then your vertices is going to be there and your vertices is going to be over here.
So an ellipse is like an oval?
Yeah, ellipse is like an oval. Alright, now this is vertical. So we know that I'm going to count up to get one vertice and down to get the other vertice. How do I know how many spaces to count? Well, I look at the biggest one, the biggest number, which is 25, and I take the square root of it. That tells me I have to go 5 spaces. 1, 2, 3, 4, 5. Boom. There's a vertice. Then I go down. 1, 2, 3, 4, 5. Boom. There's another vertice. And just to label everything and kind of teach you guys where everything's at, this is your center right here, also known as HK. Now on this particular graph, it's 0, 0. I don't like formulas, but a lot of students do like formulas, so I'm going to give you guys some formulas here. This vertice right here, what are the points for this vertice? Give me general terms, not actual numbers. What are the points for this vertice? It's an H, just like the center, right? The H doesn't change, but the K changes. But how many spaces did we go up?
5.
We went 5 spaces. So you would go K plus 5. But let's keep it really general. Instead of saying 5, what would you put right there? A. The square root of a squared is a. So the distance between here and here is a. And this is known as your major axis. The major axis is what connects the vertices. So this would be K plus A. What would this one be down here? It'd be H, K minus A. Oh, very nice. You guys with me? Okay, so now let's do the co vertices. To find the co vertices, we're going to use the square root of 16, which is our B. And we're going to count out, so it's 1, 2, 3, 4. So we put a co-vertice there, and we put a co-vertice on the other side. Count out 1, 2, 3, 4. There's your other co-vertice. And you can write that as, man, I think this is so confusing, but I think some of you guys like this. I don't know why. H plus B, K, and then this other one right here would be H minus B, and then K. Now you can draw your ellipse. There's another point, actually 2 points in this, that are called foci. Foci. F-O-C-I. Some say foci. That's just a plural form of the word focus. To find the focus, you need the C. The focus point is going to be somewhere around here. This is not exact, but this is your focus point. And you find your focus point by counting C spaces on the major axis. And so you're going to count the same way that you count for the vertices. And how do you find C? You find C using a squared minus b squared equals c squared. And so you got to take the a squared, which is the 25, and the b squared, subtract it from that, and then find out what c squared is. So let's just see what that looks like for this problem right here. A squared is 25. We're going to subtract 16. That equals c squared. 25 minus 16, that's, is that 9? That's 9, huh? Oh, that's pretty nice. And so c squared, what's c actually going to be? C equals 3. Actually, plus or negative 3, right? Which it makes sense, too, because we got to count up 3, 1, 2, 3, and we got to count down 3, 1, 2, 3, to find our foci. And you can also make formulas for these, kind of using the same notation here and here. But instead of adding and subtracting A, you would add and subtract C. That was a good question. I want to put it in the video. If, like, let's say, okay, this one was nice. Oh, man, I like my orange hand. Oh, dang it. Oh, everything. Oh. Okay, I'm totally wasting time right now. Sorry. All right, this one works out nice and pretty. It's a perfect square. But let's say it didn't. Let's say c squared equaled 8. And so then I square root both sides, and I have c equals square root of 8, which simplifies to 2 square root of 2. So if that's c, you have an idea still where the point goes, don't you? And if you don't, then yes, use your calculator. Go 2 times the radical 2, and you'll get a crazy decimal. You'll have an approximation of where your point is. Actually, that's not a bad idea, using the decimal of this to find out where the point goes. But like, if you were just writing out the point like this, leave it in radical form, because that's more exact than a decimal. Now, what is the foci for? The foci actually defines this ellipse. If you pick any point on this graph, and the graph is the oval, the ellipse. If I pick any point, that point right there is going to be, what you do is you take this distance right here, and this distance right here, and, I don't know, it satisfies, what is it, the Pythagorean theorem, but kind of backwards. So, this squared equals this squared right here. Yeah? So, in short, you only need 2 focus points to draw an ellipse. Pretend this line right here, the purple right here, pretend this is a string. And then I could take this point and go all the way around this circle. And that string would be the same length all the way around. It's really neat. I have a cool activity that shows you guys how we can create an ellipse using the 2 focus points. I just don't know if we're going to have time for that.